Let's roll. Okay, today, again, I'm taking this Hills and SAS business up to an honors level. So I'm not just, in this problem, you can see already, I'm looking for 3 side lengths. I just don't want 1. So don't be surprised if we just don't set up Hills, cross multiplying, we're done. That was the homework last night. Now I want all 3 sides. So again, a couple things we can use. You got Hills. Because look, I got my diagram, right? Do I have a right triangle? Yes. Did I draw an altitude coming from the right angle? Yes. So I can use Hills. I can use SAS. And let me bring this up. It was brought up in homework earlier, but guys, you have 3 right triangles. 3 of them. So if needed, you can do Pythagorean theorem. So don't keep that in your back pocket. All right, that Pythagorean theorem, if it can be used, go ahead. That's fine. All right, I'm going hands off here. We don't have to go in alphabetical order either. Anything you think you can find right now. Anything, X, Y, or Z, using Hills, SAS, Pythagorean theorem that I have enough information for. Radhika, start us off.
You can use SAS to find X. You can put the segment 1 over 3 equals...
Whoa. If you're going to use SAS, what's the A stand for in SAS?
Oh,
altitude, right? I want to stay away from SAS here because if I do that, I'm going to have a Y and an X in my proportion. So let's stay with SAS. It's all right. Maeve. Okay, here we go. Maeve in class says, hey, we can find Y using Pythagorean theorem. Everyone now, find what triangle Maeve is talking about that we can do Pythagorean theorem to find Y on. Because I'm going to call on somebody right now to plug in for A, B, and C. Find which one of the right triangles she is talking about, where I can find Y using Pythagorean theorem. All right, here we go. Plug in the values for me. I'm going to do a heck of a better job calling on more and more people in class. 4, here we go. Gideon, plug in the values of the right triangle that we're going to use Pythagorean theorem on.
1 squared plus Y squared equals 3 squared.
All right, let's get to it. Let's grind away here. So we got 1 plus Y squared equals 9. Move the 1 over. Y squared equals 8. And yep, you're in honors. I don't want decimals. So take your time right now. I'm going to ask somebody in a second, what does radical 8 break down into? And that's the same directions on your homework tonight. If necessary, leave it in simplest radical form. And in this case, we can. So break down the square root of 8. All right, what did you have when you break down the square root of 8? If you're still working, that's fine. Keep working. 2, 1 here. Zach, what do you got? 2 radical 2. Yep, there we go. So Y is 2 radical 2. I recommend you put it on the diagram because you never know. Maybe I'm going to use 2 radical 2 when I find X or Z. Done. Y's out of the way. All right, look at your diagram now with 2 radical 2 plugged in. What variable can I find now? X and Z. What variable can I find now? I don't think I can use any more Pythag here. So that's out. So somebody's going to have to give me a Hills or SAS to find X or Z here. I'll let you guys look. I'm not going to call anybody. I'll just listen to people who have an idea here.
You can use Hills to find X.
Any suggestions at home? I got it.
Can you use Hills to find X?
That is confirmed. Somebody in class has said that as well. Now I got 2 people saying it. Yes, we're going to use Hills to find X. Let's do it. H stands for the hypotenuse on the big triangle. Somebody express to me what the length of the hypotenuse is on the big right triangle. 1, here we go. Anthony, what do you got for me? How long's the big hypotenuse on the big triangle?
X plus 1.
Good job. X plus 1 over now. I'm going to need a leg. I got 2 legs in the diagram. Be smart with the one you pick. I'm already using X. I do not want to introduce a new variable. So which leg out of these 2 am I going to use? 2, 5. Sabrina, hello? 3, yes. I don't want to use leg Z because then I'll have an X and a Z. All right, 3 and 3. Remember, legs are the same in hills because of the means. Ooh, now we get to the good stuff. Sabrina picked leg 3, which means what segment do I need to pick? The adjacent one, remember. The adjacent one, which is, let's keep it rolling. Quincy, which segment am I going to use?
1.
1. The one next to 3. There you go, guys. Done. Done. X plus 1, when I cross multiply the extremes, are the same as equal to 9. Woo! X equals 8. Yeah. All right, now we're rolling. All right, now I just got little old Z left. Find Z. We could find Z 2 different ways. 2 different ways we could find Z. You have enough information to find Z 2 different ways. And I'm actually going to show both ways, but
Can you do it 3 different ways?
you could do it, never mind, you could do it 3 ways, yes. Using, I didn't see the big triangle. Yep. So 3 ways for you. 3 ways, how about that? Here we go, Sean. Give me a way I could find Z here.
Pythag.
Okay, I can do Pythag. Now I'm going to, you got to get a little bit more detailed for me, Sean, because I can use Pythag on 2 different triangles here. Which triangle are you going to do Pythag on?
The big one.
Okay, the big one. All right, that's fine with me. So we'll do it this way, guys. We're doing Pythagorean theorem on the large right triangle. Large right triangle. So I'm going to ask somebody to fill in values for me. What goes in for A, B, and C here? Big right triangle, Pythag. 2s, here we go. Hannah, hello. Yep. There, perfect. 9. Make sure you guys have 9 in there. That's the length of the big hypotenuse there. Perfect. So you guys got 9. Z squared equals 81. You move the 9 over, you get 72, and I'll let you guys do your magic on the square root of 72. You got it. You got it. And just a little tip for some of you guys, 9 is not the biggest perfect square. Keep going. Keep going. What do you got for me? Square root of 72 all broken down. 2, 5. Here we go. Back to you, Sabrina. Go ahead. Good job. 6 radical 2. The number perfect square you guys were looking for was 36. Good job. All right, before we move on, don't move on anywhere. Don't move on. I want to show you something. All right, grab your calculators right now. Grab your calculators. Another way we could have found Z was doing the Pythagorean theorem on the small right triangle here. We would have said what? 2 radical 2 squared plus 8 squared equals C squared. I just want to show you properly how to put 2 radical 2 in your squared in your calculator. All right, because watch me do it here. If I do this, 2 radical 2, how about I put a 2 in there? 2 squared. That's not the correct answer. 4 is not the correct answer. Do you know what your calculator is squaring? Just radical 2. And what do we want to square? The whole darn thing, right? So make sure when you are squaring a radical, please put it in parentheses. Watch the difference now. Parenthesis, 2 radical 2, all of it squared. A little bit different answer now. Okay, a little bit of a different answer. All right, so in your calculators tonight over the weekend, if you are using Pythag and you are squaring a radical, put it in parentheses. All right, because if you don't, you'll get a totally different answer, as you guys can see here. All right? All right, good job on that first one. Good job. Let's see what you got on the next one, because you guys know one doesn't make you great. Find X and Y on this diagram. And how about my hint, huh? Think about old stuff to get started. What a great hint, Mr. Carlino. Think about old stuff. Okay, I'll just think about you. You're pretty old. All right, think about old stuff. All right, well, I start thinking SAS maybe, but I'm not going to use that because I'll have X and Y in the same proportion. All right, hills? I don't know about hills either, guys, right? Because the H stands for hypotenuse, and that would be X plus Y. That's a no-go. Son of a gun. Hills and SAS, I'm not going to get right away. All right, so back up. Back up. Look at the diagram. Is there any segment up there you can find right now? Okay, hills and SAS isn't going to cut it. We'll wait on those. Back up a little bit. Is there any segment in the diagram you can find, though? Yes, you can. You can. Go ahead, Radhika, go ahead.
The whole length of the hypotenuse.
Can't you find the hypotenuse of the big right triangle? Take a look, guys. Find the hypotenuse of the big right triangle. So that's where I'm going to start. Little Pythagorean theorem to find the hypotenuse on the big right triangle. So go ahead. Somebody plug this in for me. 1/8. Here we go. Owen, what are my two legs on the right triangle to plug in for A and B?
15 squared is 1 squared.
Good. 15 squared plus 20 squared equals C squared. You don't need to put X plus Y squared. I'm finding the whole thing. All right, go ahead, guys. You guys can take over here. You should be able to find the square root. No need to break it down. Just take the square root of it. All right, what do we end up with? 25? All right, so the length of this whole hypotenuse, 25. All right, guys, can we talk hills and SAS now to find a variable? I think we can. I think we can talk hills or SAS here. Which one, hills or SAS here, can we find X or we can find Y for? Either one. What are you looking at here? 1/7, here we go, Maeve. Hills, yep, we're going to use hills. We can't, again, guys, we can't use SAS. We know nothing about the altitude. Nothing. All right, what's H going to be here? Hypotenuse length. What do you want me to plug in for H? 24, here we go. Emily, what do you want me to plug in for H?
25.
25, good work, Emily. 25, over, leg. This is a choice now. You're not going to be wrong. You're not going to be wrong with whatever leg you find. Maeve?
15.
Sure, we'll go 15. So Maeve says plug in 15. She could have also said 20. It would have been fine. Now here is where you got to be careful. She chose the leg of 15, so we're finding what variable for the segment then. Ooh, there we go. 3. Omni, which segment we're going to find if we're doing a leg of 15?
X.
Good. The one adjacent. Good. You guys are picking that up. There you go. Let's cross them up. 25x equals 225. Divide both sides by 25. How many quarters are in $2.25? 9. So X is 9. All right, I'm like you guys. I want to work quick as possible and get through this so I can end it and get on with my own life, all right, and not do hills and SAS problems. I really don't feel like doing hills again to find Y, and I don't think I need to. Do I need to use hills again to find y? No. Anybody got a little quicker way to find y now? A quicker way to find y other than doing hills. I could do hills again if you're comfortable doing that. Got a quicker way of finding y. Go ahead, Rebecca.
Pythag.
Even Pythag.
Yeah, can't you use 15 and 9 to find the altitude, and then use and then use the altitude and the other one to find y?
You can, but didn't I just say quicker?
Oh.
I think you're just adding on more work for me if I just didn't use hills. Yeah, you can do that. That's fine. Those are other options, but I do want some of my personal time. What's up, Emma? Hey, don't I know the whole hypotenuse is 25? So I take 25 minus one of the two parts I just found, 9, and there we go, 16. There we go. Whew. Just a bit, maybe by a second or two, a little quicker. Everyone at home all right? No issues? Guys here all right? All right. Let's see what you think about this one. Finding x here. Again, I got to emphasize every problem we do, make sure you have a right triangle with an altitude starting from the right angle. Only time I can do hills and SAS if I have this special type of diagram. All right, take a look at what I gave you. What can I use here now to find x? What am I allowed to use here now? Come on, we got it. Emily, going back to you. What can I use here to find x, Emily?
SAS.
Darn right. There you go, Emily. All right, we're at the point in class where I'm just going to call on one person and I want you to fill it all in for me instead of going piece by piece. So go ahead, fill it all in for me here. Ooh, 15. Will, fill it all in for me, Will.
X plus 15 over 10 equals 10 over x.
Perfect. Remember, the altitudes are the same because of the means over x. Good job, Will. All right, let's do it. X squared plus 15x equals 10 times 10, 100. It's not going anywhere, not going anywhere. Yes, you have to factor here. Don't even try to take square roots. Oh, boy. Move the 100 over, please. Yes, you could use quadratic formula. You can factor this, though. It's factorable. So go ahead, start turning the wheels, playing around with numbers in your calculator. That's part of being an honors math here. Numbers that multiply to 100 but are 15 apart will give you 15 somehow. Start thinking about it, playing around in your calculator. If you guys are using quadratic formula, keep going. Then keep going. Don't wait for us because I'm not going to do it using quadratic formula. Keep going. Two numbers that multiply to 100, 15 apart. Ryan, anything coming to mind?
-5 and 20.
Good job. The numbers were 20 and 5. Perfect. 20 and 5 multiply to 100, and they're 15 apart. I got to put plus 20 and minus 5 to make sure they add to 15. All right, you guys know the last step, right? Set each of them equal to 0, and let's solve this sucker. X plus 20 equals 0. X minus 5 equals 0. X equals -20. X equals +5. Anybody want to talk to me? Anybody want to talk to me here? There's a diagram. Yeah, and what happens when I plug in -20? Both segments would be negative, right? If I plugged in -20, no go, reject it. Only answer I can have for X is 5.
Will there ever be something where there can possibly be a negative side?
No.
Good.
Never. You cannot be a -4 feet tall. All right.
I think she meant like, will there be a situation where x comes out as negative, but in the diagram it's like x plus like.
Or x comes out to be, do you mean x comes out to be negative and we don't reject it?
That's not what I was just talking about if there's ever I know that sometimes if you substitute back in, it can be a negative number, but can still
Yeah,
turn
but
out
no, there
positive. But
will never be a time where I accept a negative side length. No.
Okay, I have a question.
Yes.
So even if the negative side length, like say it's just x plus 15, but like x comes out to be like -2.
It's fine.
So it would still count, right?
Yeah.
Okay.
Just as long as it doesn't give you a negative side length. Yep. All right, last one. Ooh, what do we think on this one to find x? I gave you the altitude. Might be a little something we could use there. Nothing about the legs, right? Nothing, so I want to stay away from that. I don't have enough to do Pythag anywhere, so let's stay away from that. But I think we would have enough information to take a look at what there. Audrey, what do we have enough information for?
We have enough information for SAS.
We-
This is really sad because Callan was just up here and I was hoping I'd get called on while she was here. She's getting coffee now, but she'll be here at the end.
Thank you.
She's going to college. She wants to say hi.
Wow, she actually made it that far, huh? Tell her I said
Yeah, she actually made
congratulations.
it that far. Good for
Wow.
her.
Yeah,
Finally, she's leaving me alone.
story of your life. All right, moving on. Joking, Audrey, joking. All right, here we go. She is correct. SAS. I got one segment. I know what the altitude is. What's the deal there? That other segment. How are you going to write that other segment in your proportion? 1, 2. Here we go. Lucas, how can I write that other segment in my proportion?
I did 26 minus x.
Darn right you did. 26 minus x, everyone. If the whole hypotenuse is 26, one piece is x, I'll subtract it and get 26 minus x. All right, perfect. We got a beautiful SAS proportion. Oh, some of you are not going to like what's going to come up here. 144. I get 26x minus x squared equals 144. And for the first time ever this year, I am actually going to move over my x squared. Why? It's negative. I don't like dealing or factoring something with a negative x squared. So yes, for the first time this year, I'm going to move the x squared over instead of leaving it where it is. So when I move it over, it becomes positive x squared. I also have to move the 26x over by subtracting it. I just asked that you put everything in a nice order. X squared, x, and then we didn't move the 144. That stays positive. I know this is not what you're going to like, but hey, welcome to honors math. There are two numbers that multiply to 44 but give you 26 somehow. And you just got to play around. Don't wait for me. Don't wait for a classmate to give it to you. Get on the calculator and start playing around here a little bit. You'll find it. Numbers that multiply to 144 but are somehow going to give you a negative 26. You can find them. What do we got? What do we find? What do you got, ladies? 18 and 8. 18 and 8. Negative 8, negative 18. Good. How'd you find those? You just played around, right? With some, yeah. Welcome to honors math. That's what we do around here. All right. We go till we get it because we don't give up. Just because, 144 is such a large number. That's not our mindset here. All right. We don't give up because they're big numbers. So here you go. Let's finish this off strong. X equals 8 and x equals 18. All Are we okay having 18 as an answer? Plug it in, doesn't give me a negative side. Are we okay having 8 as an answer? Plug it in, not giving me a negative side. So here's an instance where we didn't have to reject anything because both of them would have gave me a positive sideline. Questions from you guys? Homework this weekend. I know it's in your packet right now and it's on the assignment sheet. Simplest radical form if it's necessary. All right, simplest radical form if it's necessary. All right, get this done and you don't have to worry about homework for another week. There will not be any homework assignments next week. Have a good night, guys. Have a good weekend.
I have a question. Carolyn just said that if I have a question, maybe I shouldn't be in honors geometry. Is that a true statement?